And welcome to this last section of material for our first unit. We're going to review lines a little bit here today, talking about a very important concept all throughout mathematics, the idea of the slope of a line. If we have 2 points here, x1, y1, and x2, y2, we can find the slope of the line which passes through those 2 points by doing the calculation y2 minus y1 over x2 minus x1. If the line is parallel to the y-axis, then the slope of that vertical line, the slope of any vertical line, is undefined. So let's just start there as we review this. Vertical lines, undefined slope. And so it'd be kind of like trying to walk up a wall. There's no way that a person can walk up this wall. If, on the other hand, we have a horizontal line, our slope is 0. If you think about walking on a floor, it's very easy to walk on. Our slope is 0. Now, we always look at lines from left to right. Look at lines from left to right, and when we look at a line from left to right, if it's going uphill, we have a positive slope. If we look at that line going from left to right and it's downhill, we have a negative slope. So that's what we mean when we say we get ready to review the slopes of lines. We can tell if we have a negative slope or a positive slope. It doesn't really matter which point we call x1, y1 and which point we call x2, y2. Alright, as long as we're consistent, we know slope, change in y, y2 minus y1 over the change in x, x2 minus x1. We're looking at negative 3 minus a negative 1 over negative 6 minus 4. We're looking at negative 2 over negative 10, which is 1/5, so there's my slope. For class discussion, please work problem number 4 and then 3 and 5 in the homework. We can see some examples of slopes here in figure 5, and I'll just kind of let you read through that. Certainly if you have questions, bring those to class. Here we go, what we talked about a minute ago, vertical lines and horizontal lines and their respective slope. And how do we remember what kind of line has a slope of 0 and what kind of a line has undefined slope? Well, if you can walk on the line from left to right and you're not going up or down, as is the case with a horizontal line here, you have a slope of 0. Unless you're Spider-Man, you cannot walk up a vertical line. So that's how we know that that notion is undefined, and so is the slope of a vertical line. We review some important forms of lines. We have the point slope form, called this because we go through the point x1, y1 with a slope of m. We have the slope intercept form where we've got the y-intercept. Guys, please always write the y-intercept as a point. It is a point on the line, and points on the line are described with ordered pairs. And then the graph has a slope of m. The general form for the equation of the line, we don't use this as much, but it is used from time to time. Ax plus by equals c. The most important thing here, we have that constant on a side by itself. So if we look here at example 2, which is problem 17 from our book, we'll see that we have 2 lines here, and they would like for us to write the slope of both of our lines. Both of those lines, the blue line and the pink line there, if you will. And we notice we have a square here, so we're going to assume the 2 lines are perpendicular. We'll notice that the slope of the blue line, the change in y over the change in x, is 5/4, and it goes through the point 2, negative 3. Now guys, there's a couple different options here. We can use the point slope form to help us do this. Alright, so y minus negative 3 equals 5/4 times x minus 2. This would be y plus 3 equals 5/4 x minus, now 5/4 times -2, that's going to be 5/2. Then we'll subtract 3 from both sides. So y equals 5/4 x. -5/2 minus 6/2 is -11/2. Or another way we can look at this, if we use slope-intercept form, y equal mx plus b, we know the y coordinate, -3, we know the slope, it's 5/4. We know the x coordinate is 2, we're going to add b. -3 equals 5/2 plus b. -6/2 minus 5/2 equals b. -11/2 equals b. So we have y equal 5/4 x minus 11/2. So either way we cut it there, we get the same result. Now for the pink line, since it is perpendicular to the blue line, remember the slope of it is going to be the opposite reciprocal. And so maybe just one more time I'll show both methods here. Y minus -3 equals a slope of -4/5 times x minus 2. Y plus 3 equals -4/5 x plus 8/5. We subtract 3 from both sides. Y equals -4/5 x. 8/5 minus 15/5 is -7/5. Or we can go with the slope-intercept form, y equal mx plus b. We know our y coordinate is -3. Our slope is -4/5. Our x coordinate is 2. And our y-intercept is what we're looking for. -3 equals -8/5 plus b. -15/5 plus 8/5 gives me -7/5, and so that's b. And we get y equal -4/5 x minus 7/5. And now, and this is a homework problem, not a class discussion problem, just a homework problem. So if you would work problem 18, please. If we look here at example 3, which is problem 24, they want the general form of the equation. Remember, that's ax plus by equals c. And here we're going to want the x term on the side with the y term, and then the constant over here by itself. We'll start out with slope-intercept form, y equal mx plus b. Y is 4, m is 2/5, x is -1. We're solving for b, so 4 equals -2/5 plus b. 20/5 plus 2/5 gives me 22/5. That's my b value. And so what we have here is y equals 2/5 x plus 22/5. Now what we want to do, remember, we need the constant on the side by itself, and we don't want any fractions, so I'm going to multiply everywhere by a 5. 5y equals 2x plus 22. 2x minus 5y equals -22, and the way we'd usually write that, 2x minus 5y equals -22. As we move along here, example 4, we need to find the slope-intercept form of the line that passes through these 2 points. First thing we need to do, find slope, which we know is y2 minus y1 over x2 minus x1. Alright, so what do we have here? 7 minus 1 over 2 minus a -3. We're looking at 6/5. That's my slope. And now, guys, pick a point. Either one, doesn't matter. I'm going to go with 2, 7 just because they're both positive. Y equal mx plus b. 7 equals 6/5 times 2 plus b. 7 equals 12/5 plus b. 35 over 5 minus 12 over 5 gives me 23 over 5, which is b. And so we're looking at y equals 6/5 x plus 23 over 5. And now, very similar to these, problems 23, 27, 33, and 34, please. Of course, if you have questions, bring those in. Two lines are parallel if their slopes are the same. They are perpendicular if their slopes multiply to give us -1. Another way to think about that, we can say M1 and M2 are opposite reciprocals. And so looking here at example 5, which is similar to 21 and 22, find the general form of an equation of a line through the point 2, -3 that's parallel to the y-axis and then one perpendicular to the y-axis. Well, let's see. Here's our point 2, -3. Now a line that's parallel to the y-axis is going to look like this. We know that vertical lines have the form x equal 2. Okay, so all vertical lines are x equal whatever constant, and then a line that's perpendicular, this would be parallel. I'll put the perpendicular in red. If it's perpendicular to the y-axis, we're looking at something like this. And of course, all horizontal lines have an equation in the form y equals the y coordinate, so that would be y equal -3, and that may be a little difficult to see. Let me rewrite that. Y equal -3. So now please give 21 and 22 a try for homework. We won't have anything there on the class discussion about those, but we will take a look at those for homework. And now, example 6 here, very similar to 31 and 32. It says find the general form of the equation passing through the point 4, 5, perpendicular to 2x minus 3y equals 7. Well, we need to know what the slope of the line 2x minus 3y equals 7 is. So let's see here, -3y equals -2x plus 7. Y equals 2/3 x minus 7/3. So the slope of the line there is 2/3, which means the slope of the perpendicular line is -3/2. So this is what I did first. Now I know that, come over here, I need an equation of the line through 4, 5, perpendicular, or with a slope of -3/2. Okay, so let's see here. Y equal mx plus b. Y equals 5. M equals -3/2 times x, which is 4, plus b. 5 equals, well, -3/2 times 4, we're looking at -6, plus b. B equals 11. And so y equals -3/2 x plus 11. And so now for your class discussion, you can work problems 26 and 30, and then for homework, 29, 31, 32, 45. And then finally, as we think about lines and their slopes, it says, given these 2 points, find the general form of the perpendicular bisector line, or perpendicular bisector L of the line segment AB. Alright, well, the first thing I need to do is find the slope. Find slope of line AB. of that line segment AB. Alright, so slope -4 minus 2 over -3 minus 1, that equals m. -6 over -4 equals 3/2. That's my slope. And now, once I have found the slope there, I know that the line perpendicular to that, line perpendicular to AB, has a slope of -2/3. And so now we need the equation of the line that has a slope of -2/3, and I need the midpoint of segment AB. So we used our midpoint formula in a previous lesson. Let's see here. -3 plus 1 over 2, -4 plus 2 over 2, so we've got -2 over 2, and then here, wow, same thing, we've got -2 over 2. So we're going through the point, -1, excuse me. So I need the equation of the line through -1 with a slope of -2/3. And maybe I'll use point slope form for you here. Maybe some of you are a little more comfortable with it. I'd like to get you very soon comfortable with both so that I can use them interchangeably. That will be the goal. Y minus -1 equals -2/3 times x minus -1. Y plus 1 equals -2/3 x minus 2/3. And so let's see here. We subtract 1 from both sides. Y equals -2/3 x minus 5/3. So what do we have? 3y equals -2x minus 5. Remember, we want this in the general form, so I'm going to add 2x to both sides. 2x plus 3y equals -5. And so now, for homework, please look at problems 37 and 38. Meanwhile, we're going to look at problem 54 from the problem set. Talking about here the blue whale, the newborn blue whales. They're approximately 24 feet long and they weigh about 3 tons. Young whales are often nursed for 7 months, and by the time of weaning, they often are 53 feet long and 23 tons in weight. Let L and W denote the length in feet and the weight in tons respectively of a whale that is T months of age. Now we're saying if L and T are linearly related, express L in terms of T. So my independent variable here will be T, and the length is dependent on how old the whale is in terms of months here. And so we can see that when they are born, 0 months, they are about 24 feet long. And after 7 months, they are 53 feet long. And so we're going to find the slope of the line here. 53 over minus 24 over 7 minus 0. Well, let's take a look. This will give me 29 over 7 for a slope. And so the length in terms of time is going to be 29/7 T, and then my y-intercept is 24. So that's part A. And we want to know what is the daily increase in the length of a young male? Well, the daily increase in length of a young male, we know that this slope represents 29 feet per month that the whale is gaining in length. So if we've got 29 feet over 7 months, if you will, we want this per day, and the problem says to use the fact that 1 month is 30 days. 1 month equals 30 days, and so our months cancel out here. We've got 29 over 210 feet per days. Alright, and this breaks down to about 1.67. Actually, I'm a little ahead of myself. This would be 29 over 210 feet per day, and that might be a little difficult to get a handle on, so I'm getting ahead of myself here. I wanted to go ahead and convert that to inches per day, 12 inches in a foot. So now my feet cancel, and this works out to be about 1.675 inches per day is about how fast this whale is growing. Now if we look at part C, they want us to relate the weight to time and days as well. And so notice here, after 0 months, this whale is 3 tons. After 7 months, this whale is 23 tons. So we're going to look at our slope here. 23 minus 3 over 7 minus 0. This is 20 over 7. This is our slope. And we're talking tons per month here. And so we're going to express the relationship here, W in terms of T equals 20 over 7 T plus 3. And they ask us in part D, what is the daily increase in weight? Well, once again, part C there, part D, daily increase 20 over 7 tons per month. And we use the fact that their 1 month has 30 days. And so we've got 20 over 210, which will reduce to, of course, 2 over 21 tons per day. And if we use the fact that there are 2,000 pounds in a ton, 2 ton, 21 days, 2,000 pounds in a ton, this gives us about 190.476 pounds per day. These dudes grow, don't they? Pounds per day. I don't really know that much about whales in general, but nice problem there to look at. Pardon me. And then finally, something that we're all familiar with. College student receives an interest-free loan of $8,250 from a relative. Well, maybe we're not familiar with the interest-free loans from relatives, but I'm sure we're familiar with a loan. The student will repay $125 a month until the loan is paid off. Express the amount P in dollars remaining to be paid in terms of the time in months. Well, folks, the amount to be paid, we're going to deduct $125 every month from the $8,250 that we have, that we start out with. So after how many months will the student owe $5,000? Well, the amount that we still owe, 5,000, equals negative 125t plus 8250. We can subtract 8250 from both sides. And so we get negative 3250 equals negative 125t. We divide both sides by negative 125. And so t equals 26. So after 26 months, the student owes $5,000. And then if we look at part C, we'll just look at our two intercepts here. P equals negative 125t plus 8250. So basically our x-intercept, we're going to let p equal 0. 0 equals negative 125t plus 8250. Negative 8250 equals negative 125t. And so t equals 66. So we're going to have the point 66, 0 on the graph. And then for the y-intercept, we're going to let t equal 0. And so we know that p is going to be 8250, giving me the point 0, 8250. And so I get ready to graph this. If I mark off the x's in tens, 20, 30, 40, 50, 60, 70. So here we are, 66, 0. And if I mark off the y-axis in thousands, 3,000, 4, 5, 6, 7, 8, 9. There's 8250. And so we plot each of these. And guys, for a problem like this, if you just want to plot the y-intercepts and mark them, I'll be fine with that. We know we have a linear relationship there. And so for class discussion, if you'd work problem 52, and then you can see the remaining problems there for homework. And that brings us to the end of our class discussions for the first unit.